Conservation of momentum is a fundamental principle in physics that states that the total momentum of a closed system remains constant unless acted upon by an external force. This principle can be applied to both classical mechanics, which deals with the motion of macroscopic objects, and quantum mechanics, which deals with the behavior of subatomic particles. In classical mechanics, momentum is defined as the product of an object's mass and velocity. It is a measure of the motion and resistance of an object to change in motion. The principle of conservation of momentum states that the total momentum of a system remains constant unless an external force acts upon it. This means that if two objects collide, the total momentum of the system before the collision must be equal to the total momentum of the system after the collision. For example, consider a simple case of two billiard balls colliding on a pool table. If the first ball has a mass of half a kilogram and a velocity of 5 meters per second to the right, and the second ball has a mass of half a kilogram and a velocity of 2 meters per second to the left, the total momentum of the system before the collision is 0.555 plus minus 0.5 x2 equals 3 kilograms meter per second to the right. After the collision, the first ball may have a velocity of 3 meters per second to the left, and the second ball may have a velocity of 4 meters per second to the right. The total momentum of the system after the collision is 0.5 by 3 plus minus 0.5 x4 equals minus 1 kilogram meter per second to the left. According to the principle of conservation of momentum, the total momentum of the system before the collision must be equal to the total momentum of the system after the collision, so 3 kilograms meter per second to the right must equal minus 1 kilogram meter per second to the left. Conservation of momentum can also be applied to more complex systems, such as a rocket accelerating in space. In this case, the total momentum of the system is the sum of the momentum of the rocket and the momentum of the expelled gases. As the rocket accelerates, the momentum of the expelled gases decreases, while the momentum of the rocket increases. The total momentum of the system remains constant, as long as there are no external forces acting upon it. In quantum mechanics, the principle of conservation of momentum is still applicable, but it is modified by the Heisenberg uncertainty principle, which states that it is impossible to simultaneously measure both the position and momentum of a subatomic particle with absolute precision. This means that the momentum of a subatomic particle can never be known exactly, but only within a certain range of uncertainty. Despite this uncertainty, the total momentum of a closed system still remains constant unless acted upon by an external force. Conservation of momentum is a crucial concept in physics, as it helps us understand and predict the behavior of objects and systems in the physical world. It is a fundamental principle that is essential for understanding a wide range of phenomena, from the motion of planets and galaxies to the behavior of subatomic particles.